Welcome you all to the video practical series. Here we'll perform the experiments related to the different subjects. I am Professor Amit Kumar Patil from Department of Electronics and Communication Engineering, School of Engineering and Sciences, MIT Art Design and Technology University, Pune. Today we will perform the experiment of the subject Electronic Modeling and Simulation Lab. This subject has been introduced in first year of engineering, second semester, BTech first year. The title of the experiment is Electronic Modeling and Simulation of a Stabilized DC Supply. So here we will be using multisim software or tool to perform this experiment. So let us come to the lab manual of the experiment, then we will perform the experiment on the multisim. So this is the title of the experiment, Electronic Modeling and Simulation of a Stabilized DC Supply. So basically in this experiment, we have to design a circuit which is capable of providing a stable DC voltage or a constant voltage or a fixed voltage. So the aim is to model, design and simulate an electronic circuit that produces a constant DC supply using multisim software or tool to measure input and output voltage, to display the input and output waveform on the oscilloscope. So we will assemble different components, join them, perform the simulation, and we have to note down the readings of input and output voltage. And finally, we will draw the graph of the circuit. We will plot the input and output waveform and show it on the oscilloscope. So here the apparatus required will be the multisim software, transformer, oscilloscope, voltage regulator IC 7805, bridge rectifier and capacitor. Theory of the experiment. So regulated power supply is used to provide a constant or fixed voltage. It converts the unregulated supply into a regulated supply. So we have to design a circuit which is capable of producing a constant voltage. So such a circuit is known as a regulated power supply circuit. So here we will be requiring different components to perform this experiment. So the different components required are transformer, rectifier, filter, regulator. So the input will be the AC voltage and the output will be a constant DC voltage. AC means the waveform which varies continuously in time with respect to changes in the amplitude. Means amplitude of the waveform will continuously change with the changes in the time. That is a AC. And DC means it will have a constant fixed or DC voltage with respect to the changes in the time. The voltage will be constant. So here the AC supply will be given to the transformer. Here we are using a step down transformer. Number of turns in the secondary winding are less than the number of turns in the primary winding. So it will act like a step down voltage. So the AC input will be given to the transformer. So here is the waveform of the AC, and transformer output will be the step down waveform. So here you can see the output of the transformer. It will be given to a rectifier. Now there are two kinds of rectifier. One is half wave, another is full wave. Half wave rectifier uses a single diode. Its efficiency is 40%, while center taped rectifier, which is a kind of a full wave rectifier, it uses two diodes. And bridge rectifier, it uses four diodes connected in the form of a bridge. So here in bridge rectifier, its efficiency is 80%. Also its transformer utilization factor is also good. So we will be using a bridge rectifier. So purpose of using rectifier is to convert the AC into a pulsating DC. So here we can see the output of the rectifier. Input of the rectifier is a AC, but output is pulsating DC. Means the negative part of the waveform will be removed here. Okay, so here some pulses will be obtained in the DC. That's why it is shown in the pulsating DC. Then it will be passed to a filter. So filter will further remove the pulses from this signal, and the filtered output signal will be the output, and it will be given to a regulator. So here we are using a voltage regulator IC 7805. So it will convert it into a fixed or constant voltage, and we will get a straight line. So this is the block diagram of the circuit. Now we will replace the block diagram with the components to get the original circuit, and we will connect them and perform the experiment. So here you can see, first is the transformer. Input will be given to the transformer. Output of the transformer will be connected to a bridge rectifier. Bridge rectifier is connected to 7805 IC via a filter, that is a capacitor, and connections are made and we will perform the experiment. We will connect the multimeter at the output to measure the DC voltage. Okay. So here input we will get from the input side, and to measure the output, a multimeter will be connected where we will get the voltage reading. So here is the observation table. Here we have to note down two readings. One is the input AC voltage, another is the output DC voltage. So it will convert input AC into a fixed or constant DC. Such a circuit is known as a stabilized DC circuit. And these are the simulation results. Okay, in this way we have to perform the experiment, connect the devices, note down the readings, and also we can connect the oscilloscope to get the waveform. So this is the overall view of the experiment. Here are some assignment questions given after the experiment, which students can refer for solving it. Now we will come to the practical simulation of the experiment. So let us open the multisim software or tool to perform the experiment. So here you can see this is the multisim software. So as discussed, to perform the experiment, first we'll assemble different components, join them, do the simulation, note down the readings, connect the oscilloscope and plot the waveform of the circuit. Okay. So go to the place, in place click on component, and from here first we will select the AC source. So go to the sources, in sources go to the power sources, and here you have to select the AC source, click on OK and put it here. The next component will require a transformer. So go to the basics. In basics, here you will find a transformer. So from here you have to select 1P 1S, that is one primary, one secondary transformer. Put it here. After transformer, we will require a bridge rectifier. So go to the diodes, and in diodes here you will find FWP, that is the full wave bridge rectifier. So click on OK and put it here in the circuit. Then we will be using a voltage regulator IC. So basically it is a 3-pin IC which has an input pin, ground pin and output pin. So purpose of using this IC is to maintain a constant voltage of 5 volt. Okay. So here you have to search LM7805. LM7805 we can search here. And we have to select this IC, drag it here in the circuit, connect the remaining components, and also we have to ground the circuit to perform the simulation, otherwise we will get the simulating error. So here go to the sources, and here you will find the ground option. So pick up this ground, put it here. One more ground we will take it here. And now after this we will use a capacitor. So go to the basics. In basics, here you will find a capacitor. So of any value we can take. Suppose we are taking a 1 microfarad capacitor. Yes, so we have taken all the components. Now connect them. So this AC source will be connected to the primary of the transformer. AC input source will be connected to the primary of transformer. The secondary of transformer is connected to the bridge rectifier. So here you can see we are connecting secondary of transformer to the bridge rectifier. Bridge rectifier is connected to the voltage regulator IC. So this voltage regulator IC has 3 pins. First pin is the input pin, second pin is the ground pin, we have to ground it, third is the output pin, we have to connect it to the output side. So this capacitor we will rotate their position by pressing Ctrl R. So rotate the capacitors, and this side of the bridge rectifier is connected to the capacitor. Positive of capacitor connected to output of 7805 IC. Pin number 2 of 7805 IC is grounded. Capacitor positive is connected to the upper line, negative connected to the bottom line, and after this we have to ground the circuit. Here also after this we have to ground the circuit. Okay. And now after this we have to connect a multimeter. So here you will find a multimeter. Connect it at the output side, positive connected to one side, negative connected to another side of the capacitor. Double click on the multimeter, and here we will get the readings of the DC voltage. Okay. So AC voltage readings are given here, DC voltage we are getting here. Now we will take the readings on the different values. So double click on this 120 and make it 50. First reading we will take at the 50 voltage. So run the simulation. This green button is to run the simulation and check the output. So on a 50 volt AC voltage, we are getting a DC of 2.8 volt. Next reading, double click on 50 and make it 75. On 75 volt AC, we are getting a DC voltage of 3.98. Next reading, make it 100. On 100 volt AC, we are getting a DC voltage of 4.3 volt. Make it 125. On 125 volt AC, we are getting a DC voltage of 4.65 volt. Make it 150. On 150 volt AC voltage, we are getting a DC of 4.85. Make it 175. On 175 volt AC, we are getting a DC voltage of 4.9 volt. Okay. So now what is the use of this voltage regulator IC 7805 is that it maintains a constant value of 5 volt. So once the output reaches the 5 volt, then even if we keep on increasing the input voltage, the output will be constant at 5 volt, it will not increase further. So here you can see that at 125 volt AC, we are getting a DC of 4.98. Now if I further increase the AC and if our output voltage becomes constant of 5 volt, then again if we keep on increasing, then that value will be constant, that is fixed. So here let us take one more reading. So 185. On 185 volt AC, run the simulation. Here you can see the output we are getting the 5 volt. Okay, so it has produced the output of constant 5 volt DC voltage. Now if I keep on increasing the input voltage, the output will be constant, it will not increase further. Decimal values may vary, but it will be a 5 volt. So let us take another reading at 200 volt. So at 200 volt AC, you can see the output we are getting constant 5.03. Again make it 225 and run the simulation. So here you can see output we are getting 5.05005. Okay, 5 volt is remain constant. Another take 250 volt AC, run the simulation, and here you can see we are getting 5.0 volt, 0.03 volt. Okay, so in this way you can perform the experiment and check the output. So here you have to note down the readings in the observation table. So this is the observation table. Input AC different voltages, output DC different voltages. Here you have to note down the readings. Okay, and after this you have to solve the assignment questions which are given at the end of the experiment. So this is all about today's experiment. Thank you all. Like, share and subscribe the channel for more such information videos.